Covered
uh, blow molding types.
types, right? Blow molding process types, right?
Yes, sir.
Okay, so today we will talk about, or we will discuss about the defects, है ना? So first of all,
Okay.
tell me what is the defects? I have started the
Uh,
lecture, right? Okay,
yes, sir.
what is
So
the
defect,
defects regarding
the
the blow
problems,
molding?
the problem either from plastic or molding or temperature or it may be anything. The deformation
Yeah.
or the quality of the product or the Paris-on length distribution or Paris-on thickness
Yes.
distribution. It may be
So
anything.
basically, it may be like flash, like whites, right?
Yes, sir.
Anna, or in other words, you can say that it is nothing but poor quality product, right? The
Yes, sir.
product has a product has a
Bad quality.
few type of defect produced into the component, right? So that
Yes,
that
sir.
is that is known as defects. Okay, so this
Yes.
we are a designer or any type of producer try to avoid or eliminate this defect, you know, to
Yes.
achieve the quality product, right?
Yes,
So
sir.
basically here you can see that. So what is the cause of this defects can be basically it may be because of the material selection, right? Because
Yes.
of the mold design, है ना? Because
Yes.
of the machine wrong setting. Okay,
Okay.
or the
Either,
process
but
control parameters.
yes, sir.
Huh. What is the meaning of machine setting means?
Like the if you provide the Paris-on
Huh.
as per the machine, it may be length or width or thickness
Huh.
or
That
the
may be the
velocity of
cause.
the Paris-on
Yes.
or the velocity of the mold closing. It may be anything.
Yeah, everything, or it may be anything into the process control. Okay, so
Yes, sir.
which is operated by the operators, right? Okay,
Either operator or process engineer.
processing generator. Yeah, bilkul. So here you can see that defects, right? So these
Hmm?
all are the defects. So, commonly defects are like wall thickness variation, है ना? So
Okay.
as we know, for example, if you are preparing any type of blow component, there will be the variation into the wall thickness, right?
Okay.
Because if we are dealing with the blow mold, so basically from the neck to the
Yes,
bottom
sir.
there is a, you can say that there will be the thickness variation, right? Because
Yes, sir.
of the geometry or the manufacturing process, right?
Design point of view.
Design, right? Okay, so what is the wall thickness cost basically? So here I'm using tables, okay, for
Okay.
in which I'm showing the defect, cause, solution, and examples of that, right? So here this is
Okay,
wall
sir.
thickness causes. So uneven Parisian expansion. So what is the reason of that? Blowing pressure,
Uh,
air pressure, you can say
uh,
that.
okay.
Okay, and the improper mold design. If your design is not in a proper way, है ना?
But wall thickness means it depends for Paris-on, right?
Yeah,
Why does it comes under mold design?
just for an example, like for example, I have a component like this type of bottle, right? This type of bottle I have,
Can.
and a can type. Okay, or here you can see
Yes.
that, yeah, this is nothing but this is the handle type portion, right?
Yes, exactly.
Okay, so here if I'm blowing the pressure here, so basically
Okay.
this was the size of the Parisian, right? So basically
Yes.
here, because of a few reason, if the neck of this bottle or the can is, you can say that it is not optimum length or width, right? Okay, so maybe it is possible that air will be not enough for
Uh,
expanding this portion, right? So
uh,
you,
but but this comes under the component design, right?
yeah, it will
But
be in
it's
component design, right? Yeah, yeah.
but it doesn't come under mold design, right?
You can say that, but basically, for example, if the component has a critical geometry or component has a feature like, so depending upon that we have to optimize the mold also, right? So
Okay.
we
Okay.
have, yeah, before mold design we have to suggest to the customer that we should change these features.
Yes, sir.
So that's why it will come under the mold design. So basically, a mold designer should have knowledge about the how to design the part.
Okay.
Understood?
Yes, sir.
So what will be the solution for that? Optimize Parison, है ना, optimize Parison programming and the adjust mold cooling. This is the one of the solution of that.
Okay. So
Okay.
that means if the Parison temperature or mold temperature, if it is high, then we need to adjust the cooling of that.
Yeah, basically, for example, before the before expanding, before the complete expanding, it is cooling, right? The cooling is very rapid. So basically, this can be the cause of that.
So if the when the Parison flows and mold closes, if it is having a complete water cooling system, then before the product before the blowing the pressure, then it can create uneven component design, uneven component
Yes, of
structure.
course. Yes. Okay. Now, just for an example of this wall thickness, that bottle with thin base and thick neck, है ना? So you any type of bottle you can find out with this feature, right?
Okay.
Okay. Flashes. अच्छा, what is the reason of flashes?
Flash means excess plastic which is around the component.
Yes. But what is the reason of that? What can be a reason?
Because of the molding close when the mold closes and when the Parison is filled and the mold closes, it can create a geometry around the shape of the component. So other than that, whatever it is available, the plastic, it's a flash.
Yes. So basically, you know about the blue matching into the tooling.
Blue matching.
Blue
No, sir.
matching. You know about blue matching.
No.
Okay. Just for example, like for example, you have a core, है ना? You have a core and cavity. Okay.
Okay.
Just for an example. Okay. And your core and cavity will be met at same base, right? At same parting line.
Oh. Yes, sir.
Right. So just for an example, this is the cavity and this is the core. So you can see here that this is nothing but this is the
The flash.
parting line, right?
Okay.
This is the parting line of the mold, right? Just
Yes,
I'm talking about the injection molding, okay?
Okay.
Just injection molding. So basically you can say that, for example, like this is the core of cavity half and this is the core half. So basically if our wall thickness is nothing but it is about to 0.5 to 2 mm, just for an example, right? This is the range of the wall thickness generally.
Okay.
So we cannot find exact for example, if this wall thickness is or any type of feature is matching with this, so you can say that basically material will not fill in proper way, right? Because of that feature.
Can you repeat this one, sir?
See, for example, you have any type of feature. So for example, as I told you, 0.5 to 2 mm is the wall thickness range, right?
Component wall
Right.
thickness range is
Wall
of,
thickness,
0.5
just for
to-
an example,
Yeah.
0.5 to 2 mm for the wall thickness of the component, right? So there is a very minor distance between them, right?
Yes, sir.
है ना, between the core and the cavity region, right? There is a
Exactly.
very little distance, you can say that,
Very
right?
small.
Yeah. So you can say that basically I will apply a blue material on the core or the cavity, and then I will match the cavity with the core. Okay. For
to
example,
get extra
yes,
thickness.
yes. For example, I'm just coloring this core portion. Okay.
Okay.
And when I will match this cavity with this, if it is not, you can say that if it is not stuck with the cavity, you can say that, right? So basically,
Okay.
you can say that the blue matching will be perfect, or core or cavity region is correct.
So that means you are saying we are creating a 1 mm extra thickness for the core.
No, not that. Core and the cavity, for example, like you have a cavity and you have a core. So there will be
Yes, sir.
always space between them, right?
Yes.
So basically, if I'm applying a paint, any type of paint, or if I'm painting on the core, just for example,
Okay.
by the color.
Okay.
by the color
Okay.
I'm just painting on the core. So basically this section should not be matched with the cavity, right?
Exactly.
So basically what I'm trying to see here, that core and cavity region are perfectly correct.
Okay.
So this is known as
So
blue matching.
aligned.
Blue matching. This is known as blue matching for the molding process. This is very important process in
But
tooling.
if we try, for suppose if there is no any paint or anything on the core, then it will be directly attaching, right?
Yeah, baby. This is the process of checking the core and cavity region, that it is proper manufacturing or not,
Okay.
right?
Okay.
Okay. For example, if it is not matching in a proper way, so basically, for example, like this is the core or this is the cavity region. So here there is no space. 1 minute. Just for an example. For example, like you have a core, right? And you have a
Okay.
cavity. Okay. Or
Okay.
this is your component. Understood?
Okay.
Okay. Or now for example, like this section, like this section, like this section, there is no when you are providing the color, complete color to
Okay.
this, right? So basically there is a color left here. It means it is possible that it will create the flashes, because yeah because it should be butt to butt, it should be butt to butt with the face, right?
Yes.
But you can say that it has a color again. Okay, if you are matching, then after the matching you find the color on the core side or the cavity side. So basically you can say that it can be create flashes. So that's why this is the checking process of that. So but you can say that both surface should be aligned in a proper way, है ना?
Yeah.
Or straightness
Yeah.
should be there, right?
Okay.
Understood? Straightness
Yeah.
or the flatness, you can say that, right? GDNT term.
Okay.
Okay, so that's why. Okay, understood. And
Yes, sir.
or basically, and this is the reason, can be reason, and excess material at the parting line due to the high pressure. Okay.
Okay.
Yeah, if we calculate wrong calculation, like for the clamping force, so maybe it is the cause of that. But in the case of blow molding, there is a less chances for that, right?
Okay.
Because we are dealing with the air pressure, that's why. Okay.
Yes, sir.
So here you can say that in the fuel tank, right, plastic jerry can or the big component, there is a possibility of making the flashes, right?
Okay, sir.
Understood? What is
Yes.
the bubbles or the air, trapped air?
So, if there is a high pressure, then with the plastic melting temperature, then it can create a bubble structure on the plastic.
It create the gases basically. It is nothing but plastic is the chemical, right?
Yes, sir.
So that produce the gases, है ना? Or the moisture, you can say that. So that moisture or the gases create the vent, create the voids or the
So
bubbles.
that means if plastic is not correct.
Yes. No.
Yeah.
Air or the gases will produce the voids. So it will be trapped. It will be trapped into the wall thickness of that, right? Into the wall
Okay.
thickness. Okay. So basically we have to create the vent holes in there. Okay. So generally,
remove the excessive air.
yeah. Generally, if we are dealing with the PET bottles, so we have to create the air vents always. Okay.
Okay.
Now instead of a blow molding, we have to create the air vent in every molding process. Right, like for example, if I'm dealing with the injection molding process, so basically we have to provide that air vents, because in injection molding also it produce a burn mark and the whites, right, into the component.
Okay.
So that's why we have to use air vent there. Okay, what is the short?
No idea, sir.
Short means incomplete filling of the material. For example,
That means Parison.
yes. For example, you have a preform. Like this is the preform, and you are supposed to expand the preform with this structure, with this bottle, complete this bottle. You can say that, right? So basically, because of the low pressure, it will be expand like less. Okay, so it is known as nothing but short
Okay.
because it is incomplete filling, right?
Yes, sir.
So because of the
Understood.
low pressure, है ना, or the maybe insufficient material in the case of Parison, right?
Okay. Yes, sir.
Okay, so there will be chances of that. Okay,
Okay, sir.
so what is the solution for that? Increase the material flow and optimize the blow pressure.
Yes, sir. So either increase the blow pressure or increase the material
This
flow.
type of defect you maybe find into the deformed detergent bottles, right?
Okay.
In which
Okay, sir.
basically generally if I'm talking about the HDPC,
PA,
HDPE
PE or
and
PC?
high density polyethylene E,
Okay.
HDPE or LDPE, right?
Okay.
So if I'm making this component with this type of material, so basically this type of short can be produced there, right?
Okay, sir.
Understood? And
Yes, sir.
generally shrinkage or the warping. So this is nothing but this is the behavior of any type of material, which is the shrink.
Yeah, you said shrinkage factor.
Yeah, shrinkage factor. So we have to add that shrinkage factor also, right? So
So
because
that
of the
means we need to
shrinkage
scale the mold.
component, scale the component by which mold will be
Uh,
scaled or mold impression will be scaled automatically.
automatically.
Okay. Shrinkage is nothing but it is the behavior of the material, right? Okay.
Okay.
So if uneven cooling there, so basically material will be warp. Okay. Or it will be shrink, right?
Okay.
Or improper mold temperature. It is also improper mold temperature. Okay.
Okay, sir.
So improve the cooling system for avoiding the warping or mold thickness should be uniform, which is not possible, right?
Uniform wall thickness, it's compulsory not possible because of the
हाँ
component design.
हाँ there is a always there is a possibility of that into the variation of the component है ना of the
Yeah,
wall
if,
thickness.
if the component is
हाँ
fixed, I mean, if depends on the component, right? If the component has a complex geometry, then we need to consider, we can't consider uniform wall thickness.
yeah, basically if I'm talking about the blow mold component, so first of all we have to design the blow mold component, right? है ना?
Yes.
But we are designing the blow mold component with the uniform wall thickness, है ना? And
Okay.
now for example it has a feature like this, it has a feature like this, it has a feature like this. So basically this is the our main bottle. You can say that this
Yes.
green section is nothing but this is our bottle structure. So because of this complexity, uniform wall thickness, achievement of the uniform wall thickness is not possible.
Possible because of the
Complex
special
geometry,
section.
है ना? Complex geometry. That's why. Okay.
Yes, sir.
So for
So that means
avoiding
the
the
only
yes.
possible solution is improve cooling system.
Yes. So for avoiding that, we have to improve the cooling system, right? Or you can say that, like if I'm talking about the cooling system, so generally into the blow molding, we will use the inline cooling, like
Okay.
this inline cooling. We cannot
Okay.
go for the critical cooling.
Like?
Critical cooling, like for example, buffel cooling. You understood buffel cooling?
No, sir, I don't know.
Buffel cooling or the bubbler cooling. So this type of cooling or the spiral cooling, we cannot provide this type of cooling into the blow molding because both are the cavity region.
Yeah.
है ना? Both are the cavity region. Like for example, like in injection molding, you can see the complex type of cooling. Okay, just
Okay.
time 1 minute. Conformal cooling. See here. This is nothing but this is the conformal cooling. See here. So is it possible to achieve this type of cooling?
No.
Not possible. So that's why we have to provide this type of cooling which is known as inline or the zigzag cooling, right?
Okay.
This type of cooling we cannot create because it need
Yes.
3D printer.
And also the mold will be consuming a lot
Mold will be
material.
costly, right? And product
Yes.
will be costly also, right? So that is not.
Yes.
This is the type of spiral cooling, right?
Mhm.
This is the spiral cooling. But with this type of cooling we have to provide into the injection molding process. But here we cannot
But it's
provide.
not possible into blow molding.
Not possible. we can provide, but using the pipes or the simple inline or the zigzag cooling we can provide there, है ना?
Yeah, yeah.
But there is no requirement for
Spiral
this
cooling.
type. Yes, understood.
Yes, sir.
Okay. Now one more thing is the burn mark. Burn mark is directly related to the bubbles. Okay. So it is also this is the produced by the airs, right? Air. Okay.
Okay.
Okay. Or excessive heating of the material or the large temperature, है ना?
Ventilation.
Higher temperature. Okay. Or as we know, poor ventilation. Okay. So that's why it is directly connected with the bubbles, right? So basically, burn mark is nothing but a component will be rusted there. Burn there.
Rust.
You can say that it produce black mark or the black spot there, right?
So because of high temperature.
High temperature.
At the mold or the Parison? Anything?
Material, like for example, like plastic material which you are using, PP, what is the melting temperature for the PP? Just for example, 160 to 170 degrees Celsius, right?
Okay, sir.
Okay, but you are providing somehow you are providing, for example, 175 to 180 degrees Celsius, for example, you are providing. So because of that,
That
because
is
of-
beyond the critical temperature.
yes, so that's why it produce the gases, and
Burn
because
mark.
of that
Okay.
excess gases and the poor ventilation, that may be a cause
Okay,
of
sir.
combination of this all these things, right? So that why
Okay.
it produce the burn mark. Basically, for example, like you have a component and you are just an example, you are filling the material from this direction, right? Now, for example, your material will be behave or flow like this, okay? And here will be the, and gases will be pushed by the material, right? And here will be your gases, which is the end point for the gases, and there is no vent solution for the gases. So basically what will happen?
For exiting.
What will happen here? Pressure,
Stuck.
pressure is increasing. So because of that pressure increasing, temperature will be increasing sudden.
Okay.
So that's why it will burn the material, right?
Okay, sir. Yes, sir.
Yeah, understood. 1 minute. And one mean pinholes in the leak. What is the meaning of pinholes in the leak?
No idea, sir.
It is nothing but it is a hole into the component.
Okay. Creates a hole.
Hole, like for example, like hole in corner. So basically material component will be filled there.
Okay.
If there is a leakage or the hole into the component, so you cannot fill any type of liquid into that, right?
Yes, sir.
So it will be fail. So what is the reason for that? Basically, hole or the pinhole will be created, or the leak hole will be created because of the weak weld line. Weak
Weld
weld
lines.
lines.
That means parting lines.
Yeah, just for an example, like for example, you are dealing with the preform, okay? Understood?
Okay.
Or you have a preform like this, right or wrong? And here, when you are preparing the preform by the injection molding, so basically you can say that here will be the weld line there, right?
Yes, sir.
Which is also known as parting line.
Okay.
So basically, when this weld line, you can say that this is the already weak, or there is a possibility, for example, like this is there is a wall thickness
Because of
around
high pressure,
Yes.
then it creates a hole.
Yeah. So basically, it will create the hole, or like this. It will create like this.
Okay.
So it will create the leak there.
Okay, sir.
Okay, generally, for example, you are dealing with the PET material, so basically it will happen there, right?
Yeah.
But there is a
because of,
less chances there.
as-
There is a less chances, but generally it is created into the bottles, है ना?
Okay, sir.
So these all are the defect which can be produced into the blow molding process. Okay, so
Okay.
this is all the solution, or this is the example where you can find this type of defects. Understood?
Okay, sir.
Okay. Now, how to prevent the blow molding defect? So, as I gave the solution already, but we can control the material also. Okay.
Okay.
To use the high quality, if we want to avoid or to prevent the blow molding defect, so we should use the good material, right?
Okay, sir.
Or the virgin material for creating the components. If we use the reuses material, right? Like recycle material. So basically there is a
So
high.
anyway, because of recyclable, the plastic loses some of its properties,
Yeah, so there is a high chances of defects, right?
defects.
Okay, and ensure the uniform molecular weight distribution for even stretching. Even stretching means you can say that this is nothing but related to the blowing pressure. है ना? Try to provide the even blow stretching blow pressure, right?
Okay, sir.
So process optimization, adjust the Parison thickness for uniform wall thickness if we are dealing with the extrusion blow molding. And control, we have to control the air pressure or the cooling rates also. So this is the key points which is very important. Okay, here you can see that for avoiding this type of defect into the mold design, so this is the our responsibility, which is the designer responsibility, that we can improve the mold design for avoiding the defects. Like venting channels should be there, right?
And
Optimize
cooling lines
the
should be
cooling
proper.
lines should be optimum, right? है ना?
Okay, sir.
Which is provide even cooling, है ना? Even try to provide the even cooling. I don't know, there is no possibility of that, है ना? I don't think about that कि there is possibility, but we have to provide the cooling uniform.
Okay, sir.
We can try, right? And ensure
Yes.
parting line alignment, which is very important. So for the proper alignment of the parting line, we can use some interlock also, right? Just for an example, like you have a bottle, like this. So you can use the interlocks. And instead of the guide pillar and the guide bush, you can use the interlock like this, interlock with the draft. Okay.
Okay, sir.
So basically, it will provide the proper parting line to the component.
Okay, sir.
Okay, understood. So